Okay, so we finished the basis of Python and all of that. So we want to start doing like the foundation of data science, because data science is actually the process of turning raw data into information that stakeholders can use. That's so you have access to raw data with no meaning, and then you analyze and extract meaningful insight from the data. That's the job of a data scientist. Although 90% of the time you are going to be trying to exploit the data, clean the data, because most data will come very dirty. So we're going to look at that when we get to handling missing data or cleaning data and all of that. But let's start with the foundation. So the foundation is that we're going to be using, there is a library in Python that's going to be your toolbox for working with data, and that is the Pandas library. So that this Pandas doesn't come built in with Python. So that's why you have to import it. If you are using other IDE like Visual Studio Code or PyCharm, you will have to install it. So just if you are using that, then you have to run this code like pip install pandas. Since you are using Python 3, pip is a command that comes installed with it. So on your command line or inside the PyCharm, you can actually install your pandas. But if you're using Anaconda, like they come pre-installed there, okay? They come pre-installed in Anaconda, so you don't have to run this code, okay? So if you have, since it come pre-installed or you have installed it, the first thing you do is to import it. So you import pandas. So I could stop here and not put as, but that means that every time I want to use some function inside pandas, I will have to write pandas. So to reduce it, to shorten it, is what we're saying, okay, import pandas as PD, so that anytime I call PD, Python is seeing it as pandas. So we call this as alias. You are going to see that too in SQL. Okay, alias. So that's that about that. So pandas has two basic types. We have the pandas series and the pandas data frame. Data frame is where we spend all our time on, but let's start with basis of series. Okay, data frame is a collection of tables or is a collection of rows and tables and columns in a table, okay? So that's what called data frame. It's like our table in Excel, which is made up of rows and columns. But a series is just a single column or a single row in your data frame. So again, a data frame is made up of rows and columns, but a series is one dimensional. It's just a single column or a single row in your data frame. Okay, so, and you can create it. So to create a series, in with pandas, since we have imported pandas as PD, just call PD. If you put dot and press tab, it tells you, it lists some of the things you can do. If I do this, you can see I have series. So it's a method. I would like you to be muted so that I'm not, we don't have some distraction. Okay, so it's a method. If you press Shift Tab, it opens the documentation for you to show you how you can define your series. You can even read it. You can see it's one dimensional ND array. Forget about ND array. By the time we talk about NumPy, you will understand it better. That's another library in Python standing for numerical Python. So it's one dimension. I told you about that. It's just a single column or a single row in your data frame. Okay, and then you need to pass. So the main thing it takes are the data and the index. Okay, you can also name it if you want to, and then you can scroll down to see an example. I'm not sure they put example here, But so that's that. So we are going to define a data and we can specify the index and you can give it a name, or name is just the name of the series. That's all. Okay, so let's say we have our data to be, I don't have to type the word data, but putting it there is good to, so that it will know the first time passing is a data. Then I can pass in my data there. So suppose I have, like, I can use different things. It doesn't have to be a number. It can be different data frame. Well, let's do, so we have 100 to these. And then if I want to pass index, I want to index it, you can also come to the index and pass in the index. The index, if you don't put index, it's going to automatically assign index to restarting from 0, just like this, like 0, 1, 2, 3, 4. But if you want an index, so if I want to get back if I want to access this, you can use the idea of indexing that we did under list and string, like the first element, if I put 0, it gives me the first number. If you put -1, it won't work in this case because it's not a list, but you can use the index. The index is 4. So if I pass in 4, it gives me the last thing. So it's not, when you pass in 0, 1, you are passing in the index. So when I pass index, so to retrieve the number, just passing the index. Index 0, it gives you 1, 2, 5. If I pass in index 2, it gives me 3, 5, 4, because that's the element for that series. So, and I could change this index. This index is here. We could change it here by specifying the index that we want. Okay, so if you do that, let's say I want to say this index, or let's create a new series. So, or maybe I use this second one to explain what I want to say. So that's that about series and all of that. Another one is still series, but now we want to use dictionary. I'm not sure. I keep on forgetting that we didn't do dictionary and all of that. Yeah. Okay. So when I say dictionary, I mean, so dictionary is a sequence of key value pair. It's defined using a curly bracket such that you have a key before colon and what comes after it is a value. For instance, if I have a state and the value is also like the name of the state, maybe Texas. I have another, maybe the next thing is name, or maybe I want to say the name of a person. The name is the key, and the value is maybe the major, and then maybe the major or level could be a key, and the value would be, let's say, 500. So this is a dictionary actually. So that's a dictionary. And if I want to access this dictionary, I access it with the key. The key at what comes before this one. The key is what comes before the colon, this. So if I want to access the major, the level of the major of this dictionary, I can just call the key. If I do that, it gives me, sorry. Oh, sorry. So I guess I didn't run this. So if we call on D1, let's say I put in states, or you can even get the keys if you specify the keys, because we call them those ones keys. Those are the keys: state, name, and level. But the key and the value is what we call an item. So if I call D1 dot, if you press tab, it tells you the items. So the items is the key and the value together. But if you call on just the values, sorry, I digress. I just want to quickly use the opportunity to explain a little bit about dictionary. So the values are what comes after the colon. These Texas, Dimeji, and 500. So if you want to access anyone, you access by the key. So the key there, we see that key is a state. So if I use this state, this should give me, you can see when I call on one key, it gives me the value there. That's Texas. If I call on another key, maybe level, it gives me the level 500. So that's that about dictionary, the key and the value. So does it make sense before I switch back to the series?
Yes, sir.
Okay, good. So now we have,
Yes, sir.
Okay, so we have a dictionary here where the key just the state, Texas. Suppose this is just the population there. Suppose this is hypothetical. Okay, so we have another state, Ohio, and we have the number, we have Oregon, we have this, and we have Utah. And then I'm saying, then we have a state here. So I want to use this as the index instead of allowing Pandas series, instead of allowing it to come up with the series for me as 0, 1, 2, 3, 4, I want to supply my own index. So I'm going to create a series out of the dictionary and then using this one as the index. But observe one thing, that when I created the data, I do not have anything called New York, but I'm supplying index as New York. Let's see what that will do. So let's call this series 2. So we call on our PD dot, so series. So in this case, my data will be the S data, and then my index will be the states. Okay, let's run that and see what we have in series 2. So now look at it, Texas. This is my index, Texas. It quickly points to the data. I saw that, okay, Texas, that's 100. Ohio has 85. Utah has 48, but New York is an index, but it doesn't have any number here, anything. So you assign NAN. Who knows what NAN stands for?
Not the number.
Great, that's not a number. So in Pandas, we represent, that means that data is missing. Okay, so that's Pandas way of representing missing data. It will represent it with NAN. Some programming language like R uses NA, meaning not available. Things like that. Okay, so it couldn't find New York. So it didn't represent Oregon because that's not an index. If I specify index as Oregon, then it will include it. If I do that and run it here, it will include it. You can see Oregon is now an index, and then it gives me the value 23. So this is an example of series, and you can exploit. You can manually check how many missing values are there. So most of the thing I'm going to show you, you can apply them on the data frame. So it will help you to understand it better. So to check for missing value, we can use, if you press tab, we can use the is null method. You can see is NA or is null. You can use any of the two. So these are methods. It's a method, so you have to end it with a round bracket. If I run this will just give me Boolean answers, because I'm saying it's going to go through the data one by one and ask a question. Is this data missing? Is it an NA? Is it not available? So the answer should be true or false. If it is available, it will say false. If it's not, it's going to say true. Okay, you can see. So it's telling me Texas has no missing value, but New York has missing value, NaN. So that's why it's saying putting true there. If you want to return just all the data, like the data that is missing, and then so you can wrap all of this around back the series itself. wrap all of these inside the series. And then this just gives you, because it's a question, you are saying use the result of this to subset the original data. So it's just going to give me back the data that is missing. So that this is how to kind of index. You can play around. You can even check which of the state has more than 50 members. So we just call, the main thing is to do SER, our series, and then divide greater than 50. But if I do this, this will just be true or false because it's a question. Okay, but remember to return the entire data, the data that we need. You have to wrap everything around the series itself. So if I do that, sorry, this should be 2. So if I do that, that gives me just the data, the series, the state that has members more than 50. Any question at this point? Are we good?
Yes, sir.
Yes, sir.
Okay, great. So we can move on to data frame. So data frame is just a generalization of series. Remember, a series is a single dimension in a data frame. A data frame consists of rows and columns, as just like a table, an Excel table. So actually, most organizations, and I believe this also should be true for companies in Nigeria, for not all companies, but for major companies, for major companies in Nigeria, meaning that most companies established should have a database, or if not a database, if they don't have a database, they will have data. I believe some have data, and their data is sitting somewhere, maybe on a local computer or in a database like MySQL or Oracle and all of that. So what I want to show right now in creating data frame may not be necessary for such company that already have data, but we're just going to go through it for the sake of exercise. So most times the organization already have a data, and then you are just connecting to the data and then manipulating. But suppose you want to create the data yourself. How do you do that? How do you create a data frame? And that's what we want to do now. So to create a data frame, let me cut these guys out. Suppose we have something like this. Oh, we don't even need this. So to create a data frame, you all start with your pandas, PD dot. If you press tab, you have data frame there. So if you want to create a data frame, you use PD dot data frame. And then if you press shift tab, so just similarly to the series, you can see the first thing it takes is your data. That's the basic thing. And then you can specify the columns if you like. Otherwise, it will pick the columns by default. So you can do all of that. And then, so we can create the data frame from here. Okay? So we can create the data frame from here. So, and then if you want to look at an example of how to create it, if you don't know, if you scroll down, it shows you an example. So you can first specify a dictionary where the key will be the column name and the value will be the rows in that column. And then this is another column, and then the values will be the rows in that column. And then you can pass that to your data frame, and that will form a data from it. So that's one way you can do that. So I could first specify that as my data and then use a dictionary. You know, we could even use this same stuff that we did before. But in this case, maybe I'll first put the data somewhere else. Maybe let's say we have a column that stands for states. And then the value, the state, so so this state will stand as the column name, and anything I specify as a list in this square bracket, they will stand for each row of that list. So I can, maybe I want to mention the state's name here, like Texas, Virginia, New York, Oregon, Utah, things like that. And then I can specify, so that's one column. So I can specify another one that stands for maybe population, things like that, pop. And then I specify the population of each one. Maybe this one is 10,000. Virginia, maybe it's just 5,000. Maybe New York, there are very, very many. So let's say this is 50,000 or 500,000. Oregon, maybe that one is just 4,000. And then the last one is just 1,500. So now I can pass that now to my data. So remember, this pandas data frame has the first argument as data. So I will just pass my data equals to this data, which is my dictionary. Okay, and that's all. So if I run it here, df, this gives me my data frame. So we call it so each row here, each column here, states alone is a series, or pop alone, population alone is a series. But the two together makes up a data frame, or what this is what we call a table. But so a table is an example of a data frame. Okay. Any question on that? So that's how to create a data frame in case you want to create it. Any question on that? Are we good?
Yes, sir.
Awesome. So, and the next thing is, suppose we have a data and we don't like the name, like maybe this is population of states, So, and then we run this way. Normally, you don't want your column names to have multiple names or spaces between them. So you want to rename that column. You want to change the name from pop of state to just population. There are a couple of ways to do that. The first one, I will show you first an inefficient way, and then I will show an efficient way. So the first way, which is inefficient, is to use, because if I call my data frame and put dots, if you want to get the columns in your data, if you put dot, press tab, dot columns. So dot columns will give you the columns of your data. You can see it gives me the states and pop. So I can simply call dot columns and then specify these dot columns to be the column name. So I will tell you the drawback of this. So I'll specify the first one, even though I don't want to change it, I still have to specify. Or let me show you, in case you didn't specify, you just go right ahead to population. You want to change that one to from pop of state, you want to change it to population. So if you run this, I'm sure you're going to get error. That's because, see, length mismatch. Expected axis has 2 elements, but I only supply 1. So this is because if I'm using dot columns, it expects you to list the ones there too, like the two, all the columns there. And then since I want to change this, I will just change it here, but I still have to list the first one. So if I do this, this will work. But the drawback of this, as you can see, if I have 20 columns and I only want to replace one of them, I must list everything if I'm using this method. And that's inefficient. What if I have 100 columns? That means I'll have to list the whole 100. So that's bad. So that's the inefficient way. So let me rerun this. And then, so let me comment out this. So the other method, which is the most efficient way, is to use the rename method. Panda has a method called rename. So you can use a rename method. For instance, if I call this dot and press tab, see, so your data frame has a rename method. So if I do this, you can press Shift Tab to see how to do it. So it tells you the mapper, things like that. So you can, and if you scroll down, you can even see an example of how to do it. So so they gave you an example. This is a data frame, and then you want to rename a particular column there. Maybe you want to rename this column from capital letter A to small letter a. You just call the rename method on the DF and specify the columns in form of dictionary. You can rename even multiple columns there using the dictionary, where the key will be the original data frame and the value will be the new column name. I mean, the key will be the original column and the value will be the new column. So that's exactly how to do that. So just call the rename, specify the columns, and in form of dictionary, where the key, the original column is pop of states, but the new one now is population. So if I do this now, this would have changed. That you can see now that this has now been changed. Although if I call DF, see, if I call DF, it's still going to have the original one. That's because there is an argument here that you have to set if you want to do that. Let me show you that argument. If you want to replace it, the in place method. In place means whatever, save the results. Like Kudus mentioned that sort, when he was doing his work, the sort method, sort it in place, meaning the effect of sorting it, was effected in the original. That's exactly what in place means. So if I set, by default, the in place is false. But if I want whatever I've done here to reflect in the original data frame, I will set in place to be true. However, I don't encourage it, because you may, if you do that, the original data frame will be has been changed. So if suppose you down the road you want to still use the original data frame to do one or two things, you will have to go back again at the very beginning to rerun it. So rather, instead of setting, I would set in place to be true, just for experiment, but I will show you what to do in case you want to do that. So if I do this now, even if I call, you can see if I call DF, it has been changed. But instead of doing that, I would have preferred that you set it to a new variable name and not use in place equals to true, so that you can still have access to the original data frame, DF. So you can set this to DF1 and run it. And set it to, so that my DF is still the original one, but my DF1 would have been, is now the correct one now. So that way I have access to the original data frame, and I'm still using a new data frame, which is the corrected version of this column. I don't know if that makes sense to you guys. Any questions so far?
It's fine, sir.
Okay, all right. If there's no question, let's move on. Now, you will not need to create a data. What if the organization has a data? Now you want to load the data from your computer. You have it somewhere on your computer. Like I told you, to download some of those data and put it somewhere on your computer. So let's say you have access to the organization data. They allowed you to save it on your local computer, and you want to manipulate it to answer some business problems. So this brings us to how to load your data. So Pandas provides a way to load your data, to load it so that you can start manipulating. Now, one of the data I asked you to load is the Gapminder data set. If you have downloaded it and extracted it, you would have seen it. So check some of those folders, you will see them, you will see it in one of the folders there, maybe class data or exercise data, just check. You have it there. And you can bring it. So what I have here is the folder, the path where this folder is sitting on my computer. Although I've even brought it into, I created a folder inside my Anaconda called data, and I put all of the data there. So this data is this gapminder here. So I'm only going to be calling it there, but you don't have to. You can call it directly from your desktop. You don't have to bring it inside Anaconda. You can call it directly, but just specify your path. Now, if you are using Windows, you have to set, if you are using Windows, you have to use R, meaning raw string. Otherwise, you get error. Or you change the backward slash to forward slash. Okay? So if you're using Windows, I'm not on Windows, I'm using Mac. So you can. But if you're using Mac, none of that applies to you. But if you're using Windows, is that you just put R, which stands for raw, before in front of the string, or you change the backward slash to forward slash. Okay, so after you've done, so I put that in a URL and I'm going to read it. So Pandas has a way of helping you to read different kind of file. You read a CSV file, an Excel file, even a SQL file, a JSON file, and any kind of file. Not all, but most. So let's call these my gap. That's the variable name. So I call on my Panda PD dot. If you press tab, PR. So you can see now, so I have different, I have read underscore CSV to read a CSV file, read underscore Excel to read Excel file. Further, you hardly see this one, HTML to read an HTML file, JSON, read underscore JSON, read underscore SAS to read SAS file. I'm not sure they teach SAS in school in Nigeria. So read XPSS. I know this one is common for some guys, at least some of you are doing project, and I know they do SPSS, even in the stats department, economics, and all of that. So you can do that to read an XPSS file, read underscore SPSS. Even a SQL file, we will do this by the time we get to integrating with Python. But we won't be using read SQL, we'll be using read underscore SQL table or SQL query. These two will be what we'll be using when we start integrating with the database from Python. So, but I know oftentimes you're going to be dealing with either read CSV or read Excel most times, but you can use any other one depending on the kind of data that you have. So in this case, since I have a CSV file, I will use read underscore CSV. Okay, then I pass in my URL. That alone will read in the data. Yeah, so if I do this, so I guess my data, okay, you didn't see, I passed in a wrong directory. So let's see. So so I guess my data is not there. Let me see where data is. Oh, reader, yep. All right, let's see. Gapminder.csv. Let's see. This is strange. I don't know if you try to read in the data. This is the data. So I guess this is messing up with my, let me see. So let me just put this now in, move it. Okay, so. Okay, so now I have the gap. So this is the data. Okay, so you can, if you're walking along, you can try to just pass in the path correctly, and then you should be able to read in the data. So I have the Gapminder data set. It's not ideal to just print everything on the screen, because what if it's a million data, it has millions of rows and all of that. Though Pandas will try as much as possible to use ellipses. As you can see here, dot, dot, dot. saying that some rows are in between there because it doesn't just want to fill the whole screen with the data. So before I move on exploring this data, so we'll start doing data science work of doing some exploration. But before I do that, I want to ask, do you have anybody with any question on how to load in data using Pandas? Any questions so far? Or are we good? Hello?
It's fine, sir.
Okay, good. So now let's start exploring. When you load in your data, there are a couple of things you need to do as a data scientist, okay? Or that's who you are training to be or to have a skill on that. So you need to explore this data. You need to check. We can quickly check some of the first few rows or the last few rows to just check. That's data quality, to check the quality of the data, to know, okay, how many, the first few rows, the last few rows and all of that. You want to check some of these. You want to check the dimensions, how many rows and how many columns are in this data. Is there any missing data there? We can even quickly do some descriptive statistics like the mean, the average, the minimum, the maximum of some of the numeric columns there. So to check the first few rows, you use the add method. Call in your data frame, dot, and press tab. You have the add data frame. This add will give us the first 5 rows of the data. Okay, so this gives us the first 5 rows. So we can see the first 5 rows. Okay, this shows the data is working well, like we loaded it correctly. You can even check the last 5 rows using the tail method. So the first 5 rows is obtained using the add. The last 5 rows is obtained using the tail method. So this gives us the last 5 rows. You can see the index starting from 1,600 to 1,007. So this gives us the last 5 rows. This gives us the first 5 rows. Okay, you can easily get the column name from here, but in case the data is large, you can manually check the columns that you have. In this case, you can easily see it. But in some cases where the data is large, you can use dot columns. Okay, and this will give you all of the column names in your data frame. So this is part of what we call, if there is anybody in statistics here, there's something we call exploratory data analysis. This is what we call exploratory data analysis. It moves beyond this anyway. It's also moving to visualization, but this is exploring your data. You check the first few rows, the last few rows. How many columns and how many, like what are the columns there? How many, you can even check the data type, column, gap, text, D types. Okay, so this tells you the column names and the data type. So it gives country as object because they're in words, that's object. Continent too, object, they are words. Year, it tells you is an integer. The 64 there is just showing the version, the bit, 64-bit integer is the main data type there is an integer. We have 64-bit, we have 32-bit, but you don't need to worry about that. It's just the way it's storing it in your computer memory that is giving you, okay? So life expectancy is float, and you can see it has decimal points. Pop, which stands for population, is an integer. This is a real world data, is a data collected over across the world. It's got Gapminder. This is GDP per capita, okay? And is a float. It contains decimal numbers. So you can do that. Or you can even check the column names and everything, the data type, using the info method. So if you do gap dots, info is a method too. So that gives you it gives you the number of observations, 1,704 rows. It gives you the data type for each of them. Dimeji, I'll take your question. It gives you the data type of each of the columns, each of the variables or the features in the data. It also tells you if there is any missing value, but it's saying 1,704 non-null. So this means that there's no missing value in this data, but we can explicitly do that as I will show you. Yes, Dimeji, your question.
So what if just only one data is floating? Let's say in a column of maybe 1,700 data, all of them are integer and just one has decimal. What will it return if you're trying to check the info? Is it
It's
going
going
to
to
return
return
it
float.
as float? Oh, okay.
Yes, it's going to return float. Yeah. Okay, so you can, another thing is you can check the dimensions. So to check the dimensions of this data, to check the dimensions of the data, by dimension, I mean how many rows, how many columns. So you can do that by using the shape attribute. Remember, I'm calling some method and I'm calling some attribute. I've explained method for you when we're dealing with string and list. Okay, a method will end with a round bracket. Attribute does not have to be. Shape is an attribute. Okay, this gives you the number of rows, which is 1,704, and the number of columns, which is 6. So that's what, so that when I say check what is the dimension of your data, we mean how many rows and how many columns. You need to start using some of these terminologies, okay? And I'll be using them for you too. All these columns, they are called features, or they are in those, for those people who are used with Excel, they call them fields, and they call the rows records. But data scientists, we call them observations. Those rows, we call them observations or instances. We call the column, which statistic people may call it variables, but we call them features. Okay, so these are the features, the column names. The rows are what we call the observation or instances. Okay, so we have 1,704 observations, and we have 6 features in the data. Okay, and you can check for missing values. You can manually check it apart from the one info gives us. I explained this under the series using the is null or is NA. So you can also do that on the data frame. Okay, call the is null method. But if I do this, also return true or false and all of that. But in Python, true correspond to 1, false correspond to 0. So if I sum it, if I do dot sum, it should give me, because it's going to sum across the column, it will sum all of this. So if true is there, 0 plus 0 plus 0 plus 1 will be 1. So if I do that and run it, this sum all the missing values across the columns, and 0, 0, 0, 0 means there is no missing value in country, no missing value in continent here. If they have, it will list them here. Okay, so having zeros here meaning this is a clean data and there is no missing value in this. However, I will be giving you data that are very dirty when we get to data cleaning, so that you can have a feel of how to clean data. Any questions so far? Dimeji, go ahead.
So what if we don't have the dot sum, the sum method added to it? Is it going to just list them out? Or
You saw what we got when we didn't put the sum. It's just going to give us in Boolean.
okay.
So that's why we sum to make it better, things like that. Okay. Are you good?
Yes, sir. My network was bad before. I didn't see that part.
Okay. Now to move on with that, let's look at how to start subsetting this data frame. Okay, we want to start subsetting the data frame. There are basically 2 things I'm going to show you. First, let's even do how do we select the data frame and all of that? How do we select it? For instance, I want to because most times the data will be large, and you don't want to, you won't most times not manipulate the entire data the way it is. You might break them into smaller chunks of data, and then manipulate them small by small, like small, some parts, just part by part. Please, I would like you to be muted to avoid noise. So I would like you to be muted, everybody. Okay, so first let's view our data again. Now, suppose I just want to select just this first column. Remember, a series is just a single column in your data frame. Let's say I want to select just the country variable, the country feature. You can use two methods. You can use the dot method, or using a column like we normally do in list or all of that. If I do dot country, if I do dot a country, which is a variable there, this will list all of the country columns for me. So this is what we call a series, because it's a single data frame. Or I could use, so that's one method, using a dot method, or I can use a square bracket and pass in the column name. I want you to be muted, everybody, please. So if you're not using a dot method, you can use a square bracket. But if you're using a square bracket, you need to pass in the variable name or the feature name inside a quote. But if you're using dot method, you don't need to specify a quote. So this is be like country. So this will still give me the same thing. But the question is, what if I want to select more than one element, more than one variables? How do you think we can do that? Can I use a dot method, and or can I just simply pass in the column names inside a list like this? What do you think? Anybody?
I think we can pass the feature name inside the list.
Okay, so like these continents, right?
Yes, sir.
When we do that, it gives us error.
I think it will pass as a list. The country and continent will pass as a list. Like we have gap, double column, and double square brackets. Then the country and continent will be there.
That's right. That's right. So if I do that, that selects it. So this is like I'm putting a list. Remember, we normally index with a square bracket. So since I'm indexing by, I want to retrieve more than one column, I will just pass those two columns inside the list, inside the square bracket, and then that gives me. So the result, if you check the type of this now, this will give me a data frame back, because I'm now having more than one column. So that is how to do that. So if you're selecting more than one variable, you use a double square bracket. So, and then I can keep on, suppose I can then begin to assess all of these. I can also do some other things, like suppose I want to check how many, like what are the categories of these continents? How many continents are listed here? I can do that. There are different ways to do that. There's something, I can count it, like select my data, select my variable continent. Let me use the square bracket so that I can make it continent. And then I can call on what we call the value counts. Value counts. Okay, value counts method. So that will count how many continents are there. So I have Africa, which occurs about 624 times. Asia, Europe, Americas, Oceania, those are the continents in my data. Okay, we could also use what we call the unique, like the number of unique continents. We could do that too, like continents And then if I do dot n unique, this could give me the unique continents there. So this just give me, I have 5 continents, 1, 2, 3, 4, 5. Those are the unique continent. If I don't put n there, if I just say unique, it gives me the unique continent, but n there stands for number of unique continents. So there are different ways. You can use the value count. So you can use the value count to not only display the continent, but also the number of times, the number of occurrences of each continent. You can use unique to just give you the unique continent, and n unique to give you the number of unique continent. If we do n unique, it just gives us 5, that we have 5 unique continents. But if you want to see the name, you can use value count or unique. Okay? And then the last thing I'll do before subsetting your data is, what if you want to check some descriptive statistics? But these descriptive statistics will only give us for the numeric columns. Okay? So column gap dot describe. So there's a describe method there. So it only picks the numeric columns, the year, life expectancy, population, and GDP. Because how does it find the mean average of a country that is in words? There's no way, it's confused. That's why by default, it will select just it will perform descriptive statistics for just the numeric columns, like mean of the year, the standard deviation, the minimum, the 25%, which is the lower quartile. For those in statistics, lower quartile, that gives us the first 25% of the data. And then the 50% stands for the median. The 75% stands for the upper quartile, or the maximum. Then it does that for each of them. So this one is good, especially when we get to machine learning, to start building model. You can easily see the ranges of your data to know whether to scale your data to the same range or things like that. Well, you get to understand that better when we get there. Okay, so, but if you still want to see the descriptive statistics on the object data type, like country and continent, you can do that, even though the result will not be meaningful. Like there is an argument here. Include is set to none. If I put include to be all, it's going to include everything. Okay. If I do that, you see, now I have country and continent, but it won't make sense. It just tells me, it tells me the main, you can see NaN, you couldn't find the mean, the standard deviation, the minimum, and you couldn't find those ones for those two. And then you will be seeing some mean NaN for these others too, when it's talking about top, frequency, or unique, things like that, because these are continuous values. This one, they are categorical values or things like that. So you could stay with the default, but if you want to see everything, you set include equals to all. Any question before we move to subsetting? After subsetting, I think that's where we might stop, like group and all of that. We just stop. That will be the end of that for today. But any questions so far? Are we good? Can I move on?
Yes, sir, you can move on, sir.
Okay, now we use the double square bracket to select and all of that. So that's one way to subset, but there is a better way. The better way to subset your columns or your rows is, there are 2 methods. One is the Loc method, L-O-C, and the other is the iLoc, I-L-O-C method. So I will briefly explain both. Okay, so suppose we want to do the same thing that we did here. We want to select country and continent for all of the rows. So let me start by using Loc. Okay, and the way Loc works is that it's both loc and iloc, which I will explain later, work the same way, except that loc, okay, let me give an example. I think that one better. Call dot and press loc. So you follow it by a square bracket. It's not a method. So a method will be followed by a parenthesis, but it's not a method. You do no. So there are two things you need to specify: your rows and your column. What comes before the colon, it should be your rows. What comes after the column should be your columns. After the colon should be your columns. So if I do rows that I want all the rows, I specify that with colon, all of the rows. And then my column, I will just specify my columns like I did in that one, country, and then continent. So if I do this will do exactly what we did, what we got up there. The reason the loc and iloc is good is that for this one, it will be difficult to select. For instance, if I tell you that select the data from 100 to 150 for just the country and continent. Hello, who is that? If like using the previous method of using double colon, if I tell you to select the data between 100 and 200 for the country and column, the country and continent, do you have an idea on how to do that? Anybody? Is there a way to do that? I want country and continent, but I want the data, I don't want it from 0. I want it at the one from 100 to 200. Is there a way we can do that? Who has an idea? Kudus, since you are a professor, is there a way we can do it?
Oh, I think how we are passing it as a list first, like gap, then dot loc.
No, without using loc. The previous method.
Okay, we just want to get 1 to 200.
So like this.
Dot
Is that what you mean?
No, since we want to get 1 to 200, yes.
I want to get from 100 to 200.
Okay. I don't know. Can we use dot edge? Then we put 200 inside the bracket.
So head will give you, if you put 200 inside bracket, it will give you from 0 to 200.
Yes, sir.
So, but I want from 100 to 200, not one from 0 to 200.
Okay. We can just then column 100 to 201.
You mean like this?
Yeah, then to 201.
So if you do now, so this will work. That's one way. Do you get? So however, this is susceptible to, you'll be limited in some ways because now, like this will work, but this will not be efficient in the long run. So that's why this loc comes in. That, okay, what if we use loc such that it will just be like whatever comes before this column is representing your row, while this is the column. So for loc, you have to specify the column name, okay? And then the column here will represent your row. For instance, if I want just the 100 to 200, I can just put that in a bracket on its own. That, okay, I want the first 100, you don't even need to put that in the column, just 100 to 201, things like that. So that we do. So everything before the comma, before the comma is the row, and everything after the comma is that column. And you can specify more than one column if you want. You can specify the pop. I think that's how it's being spelled. Yeah. So you can specify that. So using loc is more efficient because you can easily specify the number of rows in that same bracket, in that same square bracket before the comma, and after the comma, you specify the columns you want to retrieve. If you don't specify it, if you just leave passing empty colon, that will mean give me all of the rows. That's what the empty colon is going to do. It will just give you all of the rows. That's all. So that's how to use the loc. So, and you can try, you can do, you can play around it. You can even select the first 5 rows for the first 3 columns, like I kind of did, like, okay, dot loc, first 5, that's colon 5. And then for all of the columns, just put colon there. That will give me the first 5 rows for all of the columns, all of the columns. You can see, just so that's what Ed is doing. Okay, and you can do that. Okay, maybe the first, or from the 5th row to the 20th row for all of the columns. That would do that. So you can do that. You can see going from 5 to 20 for all of the columns. You can use dot loc, and you can also specify, but if you need specific column names, you have to specify the column names. Okay, column names. If you just need one, maybe year, you don't need to put that inside a square bracket. But if you need more than one, then you have to specify that, maybe year and pop, things like that. So then that will give you, for just year and pop, starting from 5th row to 20th row. So using loc is very flexible, and you can manipulate your data the way you want. Now, an alternative to this. So what if I want to get the last row, just the last row, this last row, using, how do I do that? The last row, just this last row alone.
You mean using the normal conventional way or the Loc method?
Anyone, try it.
Okay, the last row, it will be loc and
so gap,
yeah, dot loc and -1 comma. Yeah, the column, the feature names.
Which feature? I said the row, I want just the last row of the entire data frame.
Okay, colon. Colon comes next.
Okay. So the rest, you can put your code there. This gives error. You can put your code in the chat. Who want to try? Anybody else? I don't even want Kudus and Dimeji. Who are they?
Can you still? Can you still?
What?
Still. Then you specify the last column.
Who is that? Is that Peters?
Yes, sir.
Okay, so he said I can use tail.
-1 or something.
-1. So that didn't work. That does a different thing. That gives us everything back when we did the tail and put -1. So you can put your code in the chat. I will continue. I will leave this until you guys solve that. I will put, so when you get it, just let me know. So I won't tell you the answer until you get it. Okay. Okay. So another one is the iLoc. So the iLoc is similar to the loc, except that instead of specifying column names, you have to specify index, the index of the column. So it works exactly like the loc, but it doesn't use column names. Instead, you have to specify the index, the position of that column names. For instance, we call on gap.iLoc, and then suppose I want to select all of the rows for the first 2 columns. That's so the disadvantage of this is that you have to know the position. So this is the entire data. Let me even call the entire data before using it, so we don't keep scrolling up and down.
Excuse me, sir.
Sorry, sir, can we use?
I've gotten it, sir.
Put your code in the chat. Okay, let me see. Okay, so I have someone put an answer. So it said look of the length of the data frame minus one, that's become the rows, okay, which is the last row for, so I want for everything. So we can simply put minus one there, colon there, right? I want for all of the columns.
Yes, sir. Yes,
not,
sir. Yes, sir.
not just those countries. So maybe, so what happened? What happened?
Are you talking to me?
Blossom, no, I'm talking to, is it Kudus that dropped the code now?
Okay.
Sir, this is not mine, sir. Mine is data.log 1703 : ::.
Oh, okay. So, someone dropped this.
No, it wasn't mine, sir.
Oh, okay.
Mine is in the chat.
Oh, okay. Let me see. Blossom, did you drop a code? Okay, so this one was from Idris. So Idris, that didn't work. And no, Kudus, what if you don't know the last number? You ask, what if you don't know the index of the row? You don't know it. So you
I have
are,
a code in the chat.
you know, Kudus, you are assuming you know it. So as you know the index, we don't know it. We don't know the last number is one. It's a billion data. The data is so large, but we want to check the first, and you can't even print it on. You don't want to use .tail to check the index. No, no, no. You just want to find out that by default, like the last row. Do you get my idea? What I'm saying? So Idris, you are still putting the same thing that we have here.
I have a code in the chat, sir.
So Idris, you are still putting this and it doesn't work. Okay. So that's it. Yeah, that's the last one there. So Dimeji, yes, I'm not sure this one will work. So this is the one you put, this is your code. It won't work, okay? All right, this is the last one I'll look at by Peters. So it didn't work. So none, okay? None. So you guys should keep battling with that. If you're not able to get it before the end of today, I will show you how to do that. But it's a simple way. It's a simple thing.
We can take it as assignment. It's because I've not been able to load my own data on my systems now.
No problem. You guys, I'm sure it's simple because you guys have done tougher.
Yes, sir. I've gotten it, sir.
I won't go back. Just put it in the chat. When I'm done, I can experiment it. Okay, let's move on. You are the one that called me back before. I've gotten it. Okay, all right. But you can put it in the chat, okay? All right, so iLoc, like I say, is exactly the same as the loc, except that instead of specifying the names like we did for the country and continent, we can just specify the index. We know country is index 0. I mean, it starts from, remember Python is 0 index. So this will be 0, continent will be 1. So if I press this 0,1, 0,1. So this gives me, you can see, instead of specifying country and continent, I specify their indices, the index of each one, and that gives me. So that's the difference between loc and iLoc. We can also specify, just like we did, like, okay, from 100 to maybe 151, that will give, and then just for, and I want to specify for the first 3 columns, that would do that. So it will go from 100 to 150 because it's not going to include this one. And then it gives me for the first 3 columns, you can see. So instead of specifying the column names as we did in loc, iLoc, you just specify the index of those columns. If I don't put the index, if I want all, I will just put colon, just like we did for loc. So that's just, so that's the main difference. The main difference between loc and iloc is that loc, you have to specify the column names, but iloc, you have to specify the index of each columns. Does it make sense?
Yes, sir.
All right. So, okay, I think this was the question I gave you there. So let me skip that. I will say come back to it. So I've explained all of this loc and iloc and all of that. I've explained that. So the last thing is group. Suppose you want to do some calculation like you would do, you are going to do in this short exercise. That, okay, we are still working with the Gapminder data set. Let me show you again. Okay. What if you want to find the average GDP per capita for each continent, like you will do in Excel? But that is a long way in Excel. You have to start putting equals to AVG or AVE, selecting the cells, selecting the GDP per capita from maybe B2 to B, all of those things. That's manual work. It's good, but it's stressful and you can make mistakes. We can easily do that here. How do you find the average GDP per capita for each continent? And that may be difficult in Excel because each continent, not just for all the continents, each continent separately, we want to find their GDP per capita. So how do you do that here? Anybody, any idea? Any idea before I quickly do it?
I have an idea, sir.
Okay, give me your idea. You're free. Give your idea, please.
Yeah, we can use the method, the value method.
What do you mean by value? Gap dot?
Yeah, dot value count. That gives us the different. No, I can't continue.
Okay. All right. You have an idea. So what we need to do, see, you need to ask a question. It starts with a question. What do we want? We want the main thing we want is average, mean, average what? GDP per capita. So we know we are going to use the column GDP per capita for each continent. So we're also using the continent variable feature. So we know two variables we're using here, the GDP per capita, the continents. Okay, but since they say for each continent, that means we need to find a way to access each of the continents there. And this is where the group by method used. We're still going to, by the time we start doing SQL, you will understand, you will see how this, most of what you can do in SQL, you can do it in Python. And most of the code you are doing there, you can also write it in SQL. They go in like into one another like that. So the first thing, so by time I need to select, so I want to group by. If I do group by what? Group by the continent. So that way, I will have access to each continent in the continent variable. So if I group by the continent, so this alone will give me access to the continent in that. Now, now I have access to each continent there, Asia, Africa, like that. How do I calculate average? I want to now calculate average of what? GDP per capita. So I need to select the variable I want to perform calculation on, and that is the GDP per cap, right? So I've selected that column I want to perform calculation on. What is the calculation I want to perform on it? Average, and that is dot mean. So I will do dot mean on it. So if I do this, this gives me the average GDP per capita for each continent. You can see this is Africa, which is the lowest, about 2,000 as at the time this data was collected. America is about 7,000, Asia about 7,009, Europe, and then Oceania. Under this Oceania, we have the Australia and maybe one other country like that. So that's how to, so if you want to access each element in a particular variable, you have to group by that variable. So that will give you access to each category in that variable. Then select the variable you want to perform calculation on, which is GDP per capita. And what is the calculation mean? And you can also do median. Suppose that's what we were told. You can do median. It will give you the median GDP per capita for each continent there. Okay, any question on that? Are we good? Hello?
Well, good, sir.
All right, so I will not do this because it's similar to some of the questions you will do here. So I will just simply put you in